Now we will calculate the base shear forces. The earthquake parameters are given as the mapped spectral acceleration for short period, the mapped spectral acceleration for a 1-second period, and the site class. We will use the table provided by ASCE standard to get the site coefficient for short period Fa and the site coefficient for long period Fv, which they depend on the soil type and the mapped spectral acceleration. Then we will calculate the maximum spectral response acceleration SMS and the maximum spectral response acceleration for a 1-second period SD1, which they are adjusted for site effects. For each mode of vibration obtained from the model analysis, we will use the response spectrum curve to determine the spectral acceleration corresponding to that mode's natural period. In order to calculate the modal force for each mode, we need to calculate the maximum response for that mode, which equals to the participation factor multiplied the spectral acceleration for the mode. The participation factor is a measure of a contribution of a particular mode of vibration to overall response of a structure. It quantifies how much a specific mode influences the dynamic response when subjected to seismic loading. The participation factor for a mode is calculated based on the mode shape and mass distribution of the structure. For our frame, the participation factor is calculated as shown. For mode 1 and for mode 2. Now we will calculate the base shear that represents the total horizontal seismic force acting at the base of the structure due to the earthquake for the mode 1 and for the mode 2. Since seismic responses from different modes can peak at different times, they should be combined using appropriate combination method to estimate the total base shear. Common methods include square root of the sum of the squares and complete quadratic combination. In this example, we will use the square root of the sum of the squares. The SRSS method is a statistical approach that assumes the peak responses in different modes are independent. By using SRSS, the responses are combined in a way that avoids overestimating the total response, which would happen if the peaks were simply added together. By combining the shear forces acting on the second floor, we will get, and for the base shear, the combination value is absolute maximum and has no direction and should be applied in positive and negative direction. In seismic design, the base shear calculated from the response spectrum analysis is adjusted as follows. The building importance factor, I, accounts for the consequence of the failure and the role of the structure plays in the community. The response modification factor, R, also known as the reduction factor, accounts for the inelastic behavior of a structure during an earthquake. Structures are designed to withstand forces less than the elastic response would suggest because they are expected to enter the inelastic range and dissipate energy through controlled damage like yielding or cracking. With the residential building, the standard importance factor equals to 1, and for the moment resisting frame, the R equals 8. Now we will move to the Etabs to calculate the base shears acting on the frame.